In June 2026, the United States Climate Prediction Center published a routine document, a monthly diagnostic discussion on the El Niño Southern Oscillation. No paywall, no login. A PDF posted to a government server, free to anyone with a browser. The document said El Niño conditions were present in the equatorial Pacific and would strengthen. It put the odds of the sea surface temperature anomaly exceeding 2.0 degrees Celsius, the threshold NOAA calls a very strong event, at 63%. 23 of 26 forecast models agreed on that outcome for the October to December window. In seasonal forecasting, that level of model consensus is close to unanimity. By the time the file went online, money had already moved. Positioning had shifted in South African maize, Malaysian palm oil, and Australian wheat. A hedge fund was weeks from opening subscriptions on a $500 million vehicle built around exactly this forecast. None of that required a secret. The forecast was public. The satellites are public. The buoy array measuring those temperatures, moorings strung across the equatorial Pacific, was paid for by taxpayers, and the United States Congress authorized sustained support for it back in 1997. So the interesting question is not who knew. Everyone could know. The question is why a free forecast still produces an enormous financial advantage, and who is structurally positioned to collect it. That gap between the moment a forecast becomes readable and the moment it becomes tradable is measured in weeks, sometimes months. It is the most reliable, recurring information window in global commodity markets, and it opens on a schedule set by physics rather than by any regulator, exchange, or company. In those weeks, a temperature reading in a rectangle of ocean turns into grain contracts, shipping rates, insurance premiums, and food inflation across 4 continents. This is not a story about weather. It is a story about the distance between information and action, and about who owns the machinery that closes it. Start with the machine itself. Along the equator, trade winds normally blow from east to west, dragging warm surface water toward Indonesia and piling it up there. Cold, nutrient-rich water rises off the coast of Peru to replace it. The Pacific tilts, thermally, like a bathtub held at an angle by wind. Sea level near Indonesia sits measurably higher than off Ecuador. El Niño is that tilt relaxing. The trade winds weaken, the warm pool slides back east, and the cold upwelling off South America stops. Meteorologists track it in a rectangle called Niño 3.4, spanning 120 to 170 degrees west longitude. When the 3-month average sea surface temperature there runs half a degree Celsius above normal across 5 consecutive overlapping seasons, it is formally an El Niño. Half a degree. That is the entire trigger. It is enough because the tropical Pacific supplies the atmosphere with a large share of its heat and moisture. Move the warm water, and you move the thunderstorms above it. Move the thunderstorms, and you shift the jet streams that steer rainfall across continents. The consequences are neither random nor evenly spread. Eastern Australia dries. Southern Africa dries. Indonesia and Malaysia dry. Peru and Ecuador flood. The American Gulf Coast gets wetter winters. Atlantic hurricane formation tends to weaken as upper-level winds shear developing storms apart. Scientists call these teleconnections, statistical links between a Pacific anomaly and weather thousands of kilometers away. The links are probabilistic, not deterministic. No El Niño guarantees a Zimbabwean drought. It shifts the odds, sometimes dramatically. 2 events of identical strength can produce quite different outcomes because the atmosphere carries other forcings at the same time: the Indian Ocean dipole, the state of the Atlantic, the slow background warming of the ocean itself. To a trader, that is not a weakness. It is the entire product. Markets price expected values, and a shift in the distribution of possible harvests is precisely what a futures contract exists to absorb. Which means a teleconnection is really a supply curve with a lead time attached. The physics arrives months before the shortage does. Almost every input to that forecast is a public asset. NOAA operates the satellites and the moored buoy array. The International Argo program maintains a fleet of nearly 4,000 autonomous drifting floats, profiling ocean temperature and salinity worldwide. The European Center for Medium-Range Weather Forecasts, funded by dozens of member and cooperating states, runs the model many traders treat as the global benchmark. Columbia University's International Research Institute publishes a monthly plume of ENSO model predictions, free. NOAA's diagnostic discussion arrives on a fixed schedule, the second Thursday of each month. Anyone can subscribe, and roughly nobody outside the industry does. The economics are unusual. In the United States, NOAA received $6.171 billion in the fiscal 2026 appropriations bill signed in January 2026, roughly $1.6 billion above the administration's request of about $4.5 billion. The agency had already lost around 600 National Weather Service positions to buyouts during 2025 and remained hundreds of staff short of pre-cut levels into mid-2026. The observing network has its own fragility. The Pacific Mooring Array was built as a joint effort, with Japan maintaining the Western Triton buoys. Reporting on the array's decline notes that only one of those Western buoys remains operational, and the Western Pacific is where El Niño events begin. So the taxpayer funds the instruments, funds the modeling, funds the scientists, and then gives the output away. That is a deliberate policy choice and a defensible one. A cyclone warning withheld from a fishing village helps nobody, and the humanitarian case for open weather data has never seriously been contested. But equal access does not produce equal outcomes. Everyone can download the same PDF on the same morning. Very few can convert it into a position before the price adjusts, and fewer still can carry that position for 8 months while it works. Which raises the obvious question. If the forecast costs nothing, what exactly are the institutions profiting from it actually buying? They are buying translation. A diagnostic discussion gives you a probability distribution over an ocean temperature. It does not tell you what happens to Malaysian palm yields 14 months later, or how many tons of maize South Africa fails to harvest, or which shipping route stops clearing its costs. That conversion is a chain of models. Take the ENSO probability, downscale it into regional rainfall and temperature. Map those onto crop phenology, when a plant flowers, when it fills grain, when heat stress does damage no later rain can undo. Then, map yield onto exportable surplus, surplus onto trade flow, and trade flow onto a futures curve with specific delivery months. Every link in that chain can be wrong, and the errors compound. Australia is the clean example. ABARES forecast the 2023 to 24 wheat crop at 26.2 million tons, against a record 40.5 million the prior season, roughly a third smaller. Getting that number right in July, rather than at harvest in December, is the difference between a trade and a post-mortem. An industry sells pieces of the chain. Atmospheric G2 supplies weather intelligence into energy trading, commodity desks, weather derivatives, and reinsurance. DTN sells subscription forecasting to agriculture and energy. Speedwell Weather specializes in weather risk analysis and the settlement data those contracts rely on. None of them generate the underlying physics. They interpret it, and they sell the interpretation to whoever pays. The pricing is revealing. Under its older costing model, ECMWF charged commercial users roughly €3,000 a year for archive access, with web products around €1,000. For a fund running billions, those are rounding errors. So the scarcity is not data. The scarcity is the analyst who knows that a dry August in South Africa's Free State province matters more than a dry August in Iowa, and who can size that conviction in contracts. Even that is not the hardest part. The hardest part is knowing when the forecast has become reliable enough to bet against consensus, which brings us to a wall in the calendar. Every ENSO forecaster fights the same enemy. It is called the spring predictability barrier, and it gives this market a season. Understand it, and the whole calendar of weather trading becomes legible, including why a fund would open subscriptions in July rather than March, and why agricultural options carry the premiums they do in the second quarter of every year. Forecast skill collapses when a prediction must cross the boreal spring, roughly March through May. The causes are physical. The ENSO cycle is phase-locked to the annual cycle. Ocean-atmosphere coupling weakens as anomalies decay. Random westerly wind bursts can push a developing event off course entirely. Models initialized in March degrade quickly beyond 6 months. Models initialized in June and July hold their accuracy far longer. The practical effect is that conviction does not build smoothly. It steps. In April, a forecast of a strong El Niño is close to a coin flip wearing a lab coat. By late June, with the barrier behind you and a measurable pool of warm subsurface water moving east along the thermocline, the same forecast becomes something a risk committee will approve. That step is the whole game. Buying before it happens means buying at pre-conviction prices, when the market still discounts the possibility. Buying after means paying for certainty that everyone else has also purchased. This is not a loophole, and nobody is being deceived. It is the ordinary structure of geophysical forecasting, and it happens to come with a calendar attached that repeats every single year. The barrier is also weakening. A 2025 study in Science Advances demonstrated that a deep learning model incorporating Indian and Atlantic Ocean conditions, not just the Pacific, can extend useful INSO prediction towards 16 months of lead time. Traditional dynamical models struggle badly past 6. Every additional month of lead time is another month of silence before the physical market reacts, widening the window in which a forecast is confident, but a price is not. The question then becomes operational. Who actually staffs a desk capable of exploiting a window like that? In 2018, Citadel assembled a team of roughly 20 scientists and meteorologists. Among them, according to reporting on the build-out, were Nicholas Klingemann, a specialist in sub-seasonal forecasting and tropical meteorology, and Nick Weber, an atmospheric scientist who had worked at the National Center for Atmospheric Research. They were not hired to publish papers. Natural gas demand is largely a function of temperature. A view on a cold snap in the American Midwest, held with confidence 3 days before consensus arrives, is worth a considerable amount of money. Citadel's commodities business, led by Sebastian Barrick since 2017, has generated around $4 billion a year in recent years, with natural gas at the center of it. Reporting on the firm describes a strategy that grew from marginal to dominant, in some years accounting for more than half of total profit, built on weather models combined with physical tracking of cargoes and storage. The model spread across the industry. Executive search firm Proco Group reported a 23% increase in hedge fund hiring of weather scientists during 2024, with compensation up 18% year over year. Bloomberg has reported top specialists commanding packages between $750,000 and $1 million. Universities that once funneled atmospheric science graduates toward government forecasting offices now lose them to trading floors. Consider what that price implies. No fund pays $1 million for someone who reads the same public forecast as everyone else. It pays for a person who can say which of the 26 models in the plume has historically performed best in this specific configuration of the Pacific and by how much to discount the others. It pays for judgment that cannot be downloaded. That is the entire business, compressed. Public input, proprietary interpretation, private position. The information is free, and the skill to use it is not, which is true of many things, from legal filings to satellite imagery. What makes this particular case unusual is the legal treatment. Unlike almost every other informational edge in finance, this one carries no regulatory shadow at all. In equities, trading on material non-public information about a company can be prosecuted. The doctrine rests on a breach of duty, owed to shareholders, to an employer, to a source of confidential information. The wrong is the betrayal, not the knowledge itself. Weather has no shareholders and owes no duty. Under the Commodity Exchange Act, superior private research is not itself a violation. Specific prohibitions do apply: market manipulation, fraud, and the so-called Eddie Murphy rule, which bars government employees from trading futures on confidential government information. But a fund that builds a better rainfall model and trades it is doing what the market expects of it. This is not an oversight in the law. Commodity markets exist to discover prices for physical goods, and superior fundamental analysis is the mechanism that makes discovery function. A trader who correctly anticipates a Brazilian drought and buys coffee is signaling scarcity to the entire supply chain months before the shortfall physically arrives. Storage decisions change, planting decisions change, importers bring purchases forward. Defenders of that structure make a reasonable case. Without speculators willing to hold weather risk, a farmer could not lock in a price at planting, and a food manufacturer could not budget a year ahead. The forecasting edge is what pays those participants to show up and take the other side. Remove the profit, and you remove the liquidity. The consequence, though, is a permanent structural gap. The forecast belongs to the public. The capacity to model it, staff it, and finance a position against it for 8 months sits with a few dozen institutions worldwide. Nothing improper takes place, and the advantage remains enormous. Both things are true simultaneously, and that tension is the honest center of this subject. It is not a scandal. It is a design. The 2023 and 2024 El Niño demonstrated what that design produces, not as theory, but as a documented sequence of disruptions running across 3 continents in under 18 months. Panama recorded its 3rd driest year on record in 2023. Gatun Lake, the artificial reservoir that supplies every lock operation on the Panama Canal, dropped to its lowest level since at least 1965. Every transit consumes fresh water, discharged to the sea and never recovered. Less rain means fewer ships. The arithmetic is brutally simple. The Panama Canal Authority rationed slots. Daily transits fell from 36 to 38 vessels in July 2023 to 24 by mid-January 2024, and to roughly 18 per day by February. At the worst point, more than 100 ships queued outside the entrances, some waiting up to 21 days for passage. The financial transmission was immediate. Very large gas carrier rates on the Houston to Chiba route reached $250 per ton in late September 2023, the highest since that assessment began publishing in 2016. Shippers either paid for auctioned slots, waited at anchor, or rerouted around Africa and added weeks of voyage time and fuel. Full operational capacity was not restored until August 2024, more than a year after the restrictions began. A waterway carrying a substantial share of United States container traffic had been throttled by rainfall statistics. Now run the timeline backwards, which is the useful direction. NOAA issued its El Niño advisory in June 2023. The relationship between El Niño and suppressed Panamanian rainfall has appeared in the scientific literature for decades. Gatun Lake's water level is published daily, in meters, on a public dashboard maintained by the Canal Authority. Every element of that trade was visible in advance to anyone who chose to look. There was no leak, no source, no privileged access. There was a public gauge reading, a public forecast, and a well-documented physical relationship connecting the two. That is the pattern worth holding on to for the rest of this. The advantage almost never comes from secrecy. It comes from visibility that nobody is organized to act on, except the small number of institutions organized precisely for that purpose. The canal was the visible failure. The next one happened underwater, and almost nobody outside the industry noticed. The Peruvian anchoveta fishery is the largest on Earth by volume and supplies roughly 20% of global fish meal. The fish depend on cold, nutrient-rich water upwelling along the Peruvian coast. El Niño shuts that upwelling down, and the biomass either dies or disperses into deeper water, where the fleet cannot reach it. In 2023, Peru canceled its first anchovy season outright. Fish meal plants shut for the first time in 3 decades. Lost fish meal and fish oil export sales exceeded $1.4 billion. Fishing sector income fell 17%, costing Peru around half a percentage point of national GDP. Roughly 18,000 fishermen lost their livelihoods across 9 months, alongside thousands of small enterprises in the processing chain. Then, the substitution began. Fish meal is a concentrated protein input for aquaculture and livestock feed, and it has no perfect replacement. When it disappears, buyers move to soybean meal. A temperature anomaly in the Eastern Pacific becomes a demand shock in the Chicago soy complex, transmitted through the diets of farmed salmon in Norway and hogs in China. Follow that chain far enough back, and it becomes familiar. In 1972, the collapse of the same fishery under similar conditions drove a historic pivot towards soybean meal that reshaped global protein agriculture for decades. The mechanism is not new. What changed is the speed and size of the capital that anticipates it, and the fact that the anticipation now happens before the fleet has even left port. This is exactly why weather desks exist, not to predict rain for its own sake, but to trace how a fish stock in the Humboldt Current reprices an oilseed contract in Illinois, and to reach that conclusion before the second market has noticed the first one broke. The chain has one more property worth naming. It runs in only one direction, from ocean to price, and never backward. No amount of capital moves the fish, which becomes politically explosive the moment the commodity in question is something people eat directly. On July 20th, 2023, India banned exports of non-basmati white rice. India accounts for roughly 40% of global rice trade and ships to about 140 countries. The stated reason was domestic food price inflation, driven partly by an erratic monsoon. Global prices reacted within weeks. Benchmark Thai white rice climbed 22% after the ban took effect, and by August, global rice prices reached their highest level since 2008. Rice feeds more than 3 billion people, and close to 90% of it grows in Asia, where El Niño typically suppresses rainfall. Importers across West Africa and Southeast Asia had no domestic buffer and no forward cover. so they absorbed the move in full, at the retail counter, within a single season. Cocoa told a harsher version. West Africa endured rainfall far above normal, then intense heat and dry harmattan winds inside a single growing cycle. Ivorian and Ghanaian yields collapsed. Cocoa futures reached roughly $12,906 per ton in December 2024, a historic peak, several times the level the market had held through the preceding decade. Coffee followed. Vietnam's 2023-24 Robusta crop fell around 20% to its smallest in 4 years after drought, pushing London Robusta futures to their highest level in more than 4 decades. Southern Africa absorbed the worst of it. Zimbabwe, Zambia, and Malawi each declared national drought disasters during 2024. Malawi's president declared a state of disaster across 23 of the country's 28 districts. The region faced an import requirement of at least 3 million additional tons of maize, with some countries losing between 40 and 80% of their harvests. Notice how a government responds under that pressure. India did not hedge. It closed the border. Export restrictions are the sovereign equivalent of a stop-loss. Crude, immediate, and devastating for importing nations holding no position at all. So one Pacific anomaly generates 3 distinct responses. A fund adds exposure, a government bans exports, a household pays more for a sack of rice. Identical information, 3 completely different sets of available options. Insurance is where weather risk gets priced formally, in public, with regulators watching. In 2025, Swiss Re Institute counted $107 billion in insured natural catastrophe losses against roughly $220 billion in total economic losses, about 49% insured, the highest share in its records. Wildfires, severe convective storms, and floods drove a record 92% of insured losses. The distance between economic and insured loss is called the protection gap, and it is where capital markets have moved in aggressively. The catastrophe bond market closed 2025 at a record $61.3 billion outstanding, up 24% from just under $49.5 billion a year earlier. Annual issuance passed $20 billion for the first time, reaching $25.6 billion across 122 transactions, with 15 first-time sponsors entering the market. The instrument is straightforward. An investor lends money to a sponsor, an insurer, a reinsurer, sometimes a government. If a defined event occurs, the principal is forfeited to pay claims. If it does not, the investor collects a spread that is often run well above comparable corporate credit. The appeal to a portfolio manager is that hurricane risk correlates with almost nothing else on a balance sheet, which makes seasonal forecasting an underwriting input rather than background reading. El Niño tends to suppress Atlantic hurricane formation by increasing wind shear across the development region. A forecaster confident in a strong event holds a defensible, quantified view on the probability of the exact trigger a hurricane cat bond is written against before renewal pricing settles in the spring. Parametric insurance extends the same logic downward to smaller policies and faster payouts. Munich Re and Swiss Re both write parametric catastrophe cover, structured as insurance, derivative, or insurance-linked security. Munich Re states most of its parametric covers sit around event return periods of 30 to 50 years, typically on 1-year risk periods. Payouts trigger on a measured index, rainfall totals, soil moisture, wind speed, with no loss adjuster and no claims process to argue over. The elegance is real, and so is the catch. A parametric policy pays on the index, not on your damage. If the rain gauge sits 15 kilometers away and reads normal, you receive nothing, having lost everything. That mismatch is called basis risk, and closing it requires better spatial forecasting, which hands the advantage back to whoever models the atmosphere most precisely. There is also a market that trades weather directly, with no crop, ship, or farm standing in between. CME Group has listed weather futures and options since receiving CFTC approval in August 1999, settled on temperature indices rather than any physical commodity. The mechanics are almost aggressively simple. A heating degree day measures how far the average daily temperature falls below 65 degrees Fahrenheit. A cooling degree day measures how far it rises above. Sum them across a contract month, multiply by $20 for United States city contracts, and that is your settlement value. Contracts exist for Chicago, New York, Houston, Boston, Philadelphia, London, Amsterdam, Paris, Essen, and Tokyo, among others, and can be traded as bundled seasonal strips. For years, this was treated as a curiosity, a footnote in derivatives textbooks, and liquidity stayed thin enough that large hedgers avoided it. That changed. In 2023, CME reported average volumes across its weather suite up more than 260% against 2022 levels, with outstanding contracts up 48% year over year as of that May. Reported figures point to a further 23% volume increase during 2025. The natural users become obvious once you look for them. A gas utility loses money in a warm winter. A ski resort loses money without snow. A power generator's summer margin depends entirely on air conditioning load. A construction firm loses working days to rain. A beverage company sells less in a cold July. Each can transfer that exposure to somebody willing to hold it. But every transfer requires a counterparty with a view. A degree-day contract is a pure expression of a forecast, stripped of supply chains, politics, and physical delivery. If your seasonal model outperforms consensus, this is the cleanest instrument in existence for saying so. The growth curve matters more than the absolute size. A market expanding at that rate is a market where a rising number of participants have concluded that forecasting skill is a tradable asset rather than an operational cost. And in 2026, that conclusion stopped being implicit and started appearing in fund documents. In June 2026, Bloomberg reported that Morton Capital Partners was raising $500 million for a special purpose vehicle built around the developing El Niño. Subscriptions opened in mid-July, targeting full commitments by the end of September, a timeline that maps almost exactly onto the spring predictability barrier clearing. The stated targets read like a list of teleconnections converted into tickers: South African maize, Malaysian palm oil, Australian and Argentine wheat, Chinese and Singaporean rubber, and the CBOT soybean complex, traded across futures, options, and swaps. Co-founder Les Finmore told Bloomberg the market was seriously mispricing the risk and described what he expected as a dramatic reshaping of the global food situation. Set that against the official forecast the fund is reading. The Climate Prediction Center put the probability of El Niño persisting into early 2027 at 97%, with a 63% chance of crossing the very strong threshold. 23 of 26 models pointed to a very strong event for the October to December window. The fund and the public agency are working from the same page of the same free document. The fund itself is not the interesting part. The interesting part is that it is visible at all. A publicly reported vehicle with a named strategy and a press cycle is the shallow end of this pool. The positions that never appear in any announcement, inside multi-strategy funds, physical trading houses, utility hedging books, and reinsurance portfolios, are considerably larger and considerably quieter. There is also a question the strategy cannot escape. Weather trades fail regularly. Forecast a drought that never arrives, and you have paid carry on a position for 8 months for nothing, then explained it to investors. The 2014 El Niño that models predicted with real confidence simply failed to develop. If you want to see what the quiet side of this looks like, following the channel is the way to catch it. Share this with someone who trades and leave a commodity in the comments you want traced end to end. Those requests genuinely shape what gets built next. The scale being traded around is easy to underestimate. In a 2023 paper published in Science, Dartmouth researchers Christopher Callahan and Justin Mencken found a persistent drag on global growth lasting years after major events. An estimated $4.1 trillion in lost output across the half-decade following the 1982 to 83 El Niño, and $5.7 trillion after 1997 to 98. For the current cycle, the Peterson Institute for International Economics has estimated that an event comparable in magnitude to 1997 to 98 would produce contemporaneous losses on the order of $686 billion, potentially rising toward $3.1 trillion over 5 years, absent policy response. These are estimates built on statistical models, and reasonable economists dispute the magnitudes. Nobody disputes the direction. Individual episodes fill in the texture. Indonesia's 1997 to 98 fires, burning across more than 6 million hectares during that El Niño, caused at least $8.5 billion in damages to forestry and farming. The 2015 fire season, under another strong El Niño, cost Indonesia an estimated $16.1 billion and generated more than 500,000 respiratory infections across the region. Those losses land unevenly, and that is the point. They concentrate in tropical, agricultural, import-dependent economies, precisely the places with the least access to hedging instruments, the shallowest local futures markets, and the thinnest fiscal buffers. A Malawian maize farmer and a Connecticut portfolio manager can read the identical CPC discussion on the identical morning. Only one of them can buy an option against it. State that plainly, and the asymmetry stops being about weather. It is not concealed information. It is unequal capacity to convert information into protection. The forecast was distributed democratically. The instruments required to act on it were not. Some institutions are working to close it. The World Bank has issued catastrophe bonds on behalf of member states, and index-based drought products now reach smallholder farmers through satellite-triggered payouts across parts of Africa and South Asia. Those programs remain small against a $61 billion cat bond market built overwhelmingly around developed market property risk. The window is about to narrow further, and the reason is not meteorological. In December 2024, Google DeepMind published results in Nature showing its GenCast model outperformed the ECMWF ensemble on 97.2% of 1,320 evaluation targets, producing a full 15-day global forecast in roughly 8 minutes on a single chip. Consider what that does to this business. Competitive forecasting once required a supercomputer, a national research budget, and a physics faculty. A model trained on 40 years of publicly available reanalysis data now runs on hardware a mid-sized fund can rent by the hour. The barrier does not disappear. It moves toward whoever industrializes the interpretation layer fastest. The underlying physics has not changed since 1997. The Pacific tilts, the trade winds slacken, the rain moves, the anchovies leave. What changed is the machinery built around it, the resolution of the observations, the speed of the models, the number of people paid 7 figures to read them, and the size of the positions available to express a view. There is a version of the next decade where that machinery gets cheap enough to reach the people who actually grow the food. Index insurance priced off an AI forecast, sold to a smallholder through a phone, settling automatically when the rainfall index breaks. The technology to do it exists right now. The distribution does not, and distribution has always been the harder problem. So the next time a government agency posts a routine PDF about a temperature anomaly in a rectangle of the Pacific, understand what you are looking at. Not a weather report, a public signal that a small number of institutions have already converted into private positions, entirely legally, using data that was also sitting on your screen. The forecast is free. It always was, and it should be. What costs money, and what almost nobody outside a few dozen buildings actually possesses, is the ability to move before everyone else has finished reading it.